So the next problem we are moving on to is LeetCode problem number 675, which has been marked as a hard level problem. It is cut off trees for golf event. So you're asked to cut off all the trees in a forest for a golf event. The forest is represented as an m cross n matrix. In this matrix, 0 means that the cell cannot be walked through it. 1 represents an empty cell that can be walked through. So 0 is blocked, 1 we can walk through it. And a number greater than 1 represents a tree in the cell that can be walked through, and this number is the tree's height. So let me just reduce the size of this. Okay, so it says if the cell value of the grid is greater than 1, it represents a tree in a cell that can be walked through, and this number is the tree's height. Okay, so in one step you can walk in any of the 4 directions: north, south, east, or west. If you are standing in a cell with a tree, you can choose whether to cut it off or not. So you must cut off trees in order from shortest to tallest. So we have an increasing order here, right? So when you cut off a tree, the value at its cell becomes 1. That is, it becomes an empty cell. So we'll have to keep, once we cut off a tree, let us say this is our grid, and we have the values 0 here, then 1, then 2, then 3. Okay, this means that this is blocked, and we are initially starting from point 0, 0. Okay, so this is also another condition. This says that if we have the grid value at 0, 0 itself as 0, that means it is blocked. So we return -1 because we won't be able to cut off any trees because we cannot start our traversal itself only. So otherwise, if you have trees like of height 2 and 3, you have to cut those off and cut them off in increasing order. So first 2 comes, then 3 will come, and then the increasing values. Let us say we have 5 and 7. So after that 5 would go, and then 7 would be cut off, and all cells would become 1 after cutting them off. That is empty cells. The input is generated such that no 2 trees have the same height, and there is at least 1 tree that needs to be cut off. Okay, so we have that given to us. Now let us go to the first example. So first example says we have this as our grid, that is forest. So you see these 2 cells are 0, so we cannot visit them, right? These are blocked. There's always a path to reach to our final one, which is the largest tree. So we start at 1, which is an empty cell. Then we cut off 2. So we have to travel in an increasing order. So the order should be increasing. Okay. So then we go to 3, then 4, then 5, then 6, and 7. So following this path from shortest to tallest, we take 6 steps: 1, 2, 3, 4, 5, 6. Okay. So that's our answer. We return 6. Now in our second example, we have as you can see, the middle row is completely blocked, and we are starting from 1. So even if you go from 1 to 2, cut this tree off, make it equal to 1, then again go right, cut this as well and make it 1. You'd say we have 2 steps, but our aim is actually to cover all the trees in increasing order fashion, and all the cells should be covered. That is, these cells should also be marked as 1, right? So we need to visit these cells as well. But due to the the middle row, these cells are blocked, so we have no path going from the topmost row to the bottommost row. So therefore we return -1. The trees in the bottom row cannot be accessed as the middle row is blocked, right? So that's our second example. And now third example, let me show you by drawing it on my own. So this is our grid, or the forest grid, that has been given to us, and we have been assigned 2, 3, 4, 0, 0, 5, and 6, 7, 8, right, in this fashion. So you can easily see that it's similar to the first example, just the values have been increased by 1, right? So we start from here, make it 1, then go to 3, make it 1, then go here, make it 1. Similarly, we make all of these 1 while visiting them, right? And the total steps it takes again is 6. So that's our answer. So now let us get to our solution part. So let me share you my solution. This is basically using BFS and priority queue. So the intuition is that we have to start at 0, 0, cut down all the trees in increasing order of height from shortest to tallest. So we can only move up, down, left, or right. So we have 4 directional movement. That's our constraint. And each move will cost us 1 step, right? And if you cannot reach the next tree, we return -1. So otherwise, we return the total minimum steps required to cut all trees. So the observations, let me just state them. First is that the trees must be cut in ascending order of height. Okay, that one we know. Then pathfinding between trees must be shortest path. Use BFS. All moves cost the same. Then after cutting each tree, your new start position becomes the tree's location. So after you have cut the tree, let us say we have the value 3 at this cell. We cut it, so the value becomes 1. Your new starting position becomes the tree's location. So you have to start from this location and then go and traverse the neighbors. Check if they are valid. That is, if the value of the grid is not equal to 0. If the grid value is not 0 in the neighbor, and if it is in bounds, that is, it does not go out of bounds, right? Then only we will explore it. So that is why we are using BFS. And if at any point a tree is unreachable, we return -1, right? So the algorithm, let me discuss the approach. So firstly, we collect and sort the trees. So we traverse the whole forest. So we go for I in range, or basically the Python one I'm telling you, but I'll code it up in C++. So for I in range n, for j in range m. So basically going m cross n, right? So for I in range m and for j in range n, we traverse the entire graph, and or basically the matrix that has been given to us. We traverse it entirely and basically store the values that are greater than 1. That is the grid value, if it is greater than 1, we store those. That means that we have trees. So this uh, basically priority queue we will be using in order to store our trees, because we need to store them in ascending order. So we use a minimum heap, right? The minimum element comes at the top, right? So let us say we have 2 as the height, that comes at the top, then we have 3, and then we have 4. So we will be extracting the elements in increasing order. So first 2 comes, then we pop this one out, 3 comes, then we pop the final one out, 2, 3, 4. So this comes in increasing order. That is why we are using minimum heap, to ensure that these are processed from shortest to tallest. And in the priority queue, we're going to be storing height, comma, x and y. That is the coordinates, and height is actually the cell value of at that coordinate, right? X comma y at those coordinates. So height of x comma y, or grid of x comma y, is actually the height, and we will storing the grid value greater than 1. Then we perform BFS on for shortest path. So for each consecutive pair, we take the current position and the next tree, that is x comma y, and the next tree, that is nx and y is grid value, right? Grid of nx and y. So we take these consecutive pairs and perform BFS to calculate the minimum steps required, and then BFS is suitable because all moves have equal weight, 1 step. Now update position. So after cutting down the tree, update sx comma sy to that tree's position, and then we calculate the total steps, that is accumulate the BFS results. If any BFS returns -1, we output -1, that is the tree won't be reachable. Now moving to the complexity part. So for collecting the trees, it would take O of m times n log t, where t is the number of trees due to min heap insertions, and m cross n. Why would we be taking m cross n? Because we are traversing the whole grid for I in range for I 0 to n m, I mean, which is the number of rows, right? And then we go for j 0 to n for all the columns, and then we calling the function. We are pushing it into the priority queue, the height as well as the coordinates. So the push operation takes log t time, where t is the number of trees pushed. So it takes m cross n for this loop and these 2 loops, and within that we are calling the priority queue dot push. So log t for that. So that is the time collection, time complexity for the tree collection. Then we have for the BFS O of m cross n times t, in worst case BFS per tree. That means if we have a skewed tree that is formed in the BFS itself, which is not balanced. So you see it is a left skewed tree, or we could have a right skewed tree as well. So in that case, we have the height of the tree, h or t. Height of the tree is equal to the total number of trees, nodes, right? So that is why log t actually becomes h or t. So that's about the BFS, and space complexity is O of n%, since we will be using a visited matrix to mark the nodes visited. Now let us get to our main problem. So main coding part. So I'm going to be using the alias name p for pair of int comma int, that will show the height of the current cell and the x and y coordinates, and directions I have assigned. So basically this means that x plus 1 comma y plus 0, we'll be adding all these. So this means that we will be going towards the next row, right? So from row 1 to row 2, let us say. So we'll be going down, since in the y coordinate we have no change. In the x coordinate we have incremented the row by 1, so it is down. So this means down. Then this means up, because we are going x minus 1 y plus 0, and this one is actually right, because we are going x remains the same, but we are increasing the column value, that is the j value or the y coordinate. So we are going from this column to this column. Let me show you in this graph, in this matrix. So suppose we are at this point, j plus 1 or y plus 1 would take you to the next column, so this one. So we're going right, and this one denotes left. So we are basically going to traverse matrix 4 directionally, the cell that we are at 4 directionally. And bool is valid function I made to check whether our the coordinates that we write I comma j, whether they are in bounds or not. So we return I greater than or equal to 0 and I less than m, that is it should be within bounds. So I basically is going to be from, I is basically denoting the row. So I starts from here, I is equal to 0 to m, which is the number of rows. So I is equal to m, this is I is equal to m minus 1 row, and this is I0. So we have to make sure that I is greater than or equal to 0, that is it falls in this range, and I less than m, right? So in this range it should be to make it valid. And for j equal to 0 and j less than n, so these are the column values, and it should be within this range of columns. So that is how we check our coordinates to be within bounds of our matrix. Now cutoff tree is our main function. So it takes the forest or the matrix, or basically we can call it the grid, as our input. So m is equal to forest dot size, which is the number of rows, and n is the number of columns. And as I told you in the first example itself, if forest of 0, 0, that is the starting cell that we are taking, that itself is 0. That means this cell is blocked. So we return -1 because the starting point is blocked itself. Now we'll be using a minimum heap, which is storing height and the x and y coordinates of that particular cell, right? So then we collect all trees and sort by height in ascending order, that is minimum heap. So the priority queue we take in this format, it is taking p as the alias name that I had set above here, right? Pair of int comma int, pair of int comma pair of int comma int, right? For height and the x and y coordinates. Now we basically traverse the whole matrix first, and we check for those values, that is those grid values which are greater than 1. Those would be the ones containing the trees. So we push into the priority queue that tree's height and the ij coordinates it is at. Ij are basically the x and y coordinates. Now total steps are basically it would return our final answer, and sx is equal to 0 and sy is equal to 0 are the starting coordinates. So we'll be starting at the top left cell, right? This cell, right? This point is our sx is equal to 0 and ssy is equal to 0. So while the priority queue is not empty, we extract the current element out and pop it out from the priority queue. Current height is current dot first, and x and y coordinates are basically tx comma ty, which are the target row and target column which we have to reach to. So here now we call our BFS function to find the shortest distance from sx to sx sy to tx ty. So sx sy to tx and ty we have to traverse using BFS. So this is our function for that, sx xy to tx ty, and m and n are the number of rows and columns respectively. Here we check if minimum steps is equal to -1, we return -1. So if anywhere we find out that it is unreachable, we return -1. And in the total steps, we increment the min steps that we receive from the BFS function. And then finally, we move our starting point to the tree that we just got. Ss is equal to tx and sy is equal to ty. So essentially what we're doing is that once we start from our sx comma sy, that is this point, then we go to our next cell. And the next cell itself would be tx comma ty, right? We check if this is already in, obviously if this is tx comma ty, this would have been popped out from the priority queue, right? So this cell is actually having a grid value greater than 1. So we would need to cut it, right? So once we move from here to here, we cut it and add the minimum steps and set the sx comma sy to these coordinates so that we can start our next iteration from here. So we move start point to the tree that has just been cut so that we can start from here and go over to the next call for BFS. And after we've done this, we return the total steps once we come out of the once priority queue becomes empty. And this is our function for BFS. So basically it takes forest sx comma sy, which are the starting coordinates, and tx comma ty target coordinates, and m cross n is basically the number of rows and the number of columns. So we check if sx is equal to tx and sy is equal to ty, we return 0 because we are already at the target cell. Now we declare a queue, right? A queue data structure we're using of the format of pair of int comma int, in which we're storing the x and y coordinates, right? And we take a visited vector of bool type to mark the nodes or the cells that we have just seen or just been to as visited, right? So basically this is also m cross n visited, right? It stores false if it has not been visited, and true will mark when we visit it. And q dot push sx comma sy. So we start from starting coordinates sx sy, and 0 steps we have taken initially. So we have assigned steps as 0, and we mark the starting coordinates as true. So now while the queue is not empty, len is equal to q dot size, while length minus minus. So we are going for the BFS standard BFS approach. We extract our row and column from the queue's front and pop that element out, and we go over all the directions. That is 4 directionally we are visiting from this particular cell, that is row comma column. These coordinates we are visiting in 4 directions, that is up, down, left, and right, and checking if the cell is in bounds, that is the is valid function would be used here. If the neighboring cell, that is the cell that we are going to, nx comma ny, right, it could be anywhere 4 directionally. So it would be here, here, or here, or here, right? So if any of these, we check if it is in bounds, and if the grid value is not 0, that means it is not yet been blocked. I mean, it is not yet it is not blocked, and it has not yet been visited, that is it is an unvisited cell. Then we have to explore this path, and then we have to go to this path. So that is why we push it into our queue, that is pushing the next neighbor, that is the next column and the next row in the column nx and y, and marking that as visited. And in this here itself, we check that if we have found the target, that is if the neighboring row is equal to the target's row and the neighboring column is equal to target's column, then we have found the target. So we return steps plus 1. And finally, after basically each level is done, we increment the steps. So after processing all the current level nodes, we keep on increasing steps. And if the function does not return here itself, that means we are not able to reach to this point. So that means either we have found that there is a, basically in the example 2 we saw, we found that we won't be able to reach to the other cells because the middle row either is blocking the reachability to other cells, right? So that would be the condition. So in that condition, we return -1 once we come out, and that means the target is not reachable. So that's it about the video.